Hello everyone, I am Anurag Lakra and my roll number is 20EC30004. I have created this solar tracker in tinkercad for DIY assignment 2. So what it does is basically it rotates the solar panel attached to it, so the solar panel will always be facing towards the sun. In this way we can utilize solar energy more efficiently. So this is my circuit layout. I have used 2 servo motors, 3 photoresistors, 3 10 kilo ohm resistors, 3 multimeters, a breadboard and an Arduino Uno. The multimeters are connected with ground and analog pin of Arduino. The 5 volt and ground pin of Arduino is connected to the breadboard. The power and ground pin of servo motors are connected with 5 volt and ground pin, and the signal pin of servo motor is connected to the digital pin 5 and 6 of the Arduino. One terminal of LDR is connected with the 5 volt and another end is with the analog pin of Arduino, and it is connected with the ground through this resistor. It is necessary to use this resistor with this photoresistor, otherwise there will be no change in voltage. Its working is simple. These 3 photoresistors will be placed in the plane of solar panel, and the below 2 photoresistors will be separated by a wall kind of structure, and similarly these 2 photoresistors will be separated by the wall. So the photoresistor in the direction of sun will receive higher intensity than the opposite one. So the servo motor will rotate the solar panel in the direction of sun, and the servo motor will be stop rotating when all these 3 photoresistors will receive equal intensity and the solar panel will be facing towards the sun. So this is my code. When the right photoresistor gets higher intensity than the left one, this if statement follows, and the angle of the servo motor increases by 1 and it rotates in anti-clockwise direction. And if the intensity on left photoresistor becomes higher than the right one, the servo angle decreases by 1 and it rotates in the clockwise direction. Same for vertical plane rotation. If upper photoresistor gets higher intensity than the lower one, the servo motor angle increases by 1 and it rotates towards the upper photoresistor. If the lower photoresistor gets higher intensity than the upper one, the servo motor angle decreases by 1 and it rotates towards the lower photoresistor. I have given a delay of 100 milliseconds after each rotation to slow down the speed of servo motor. So let's start the simulation. These 3 multimeters are showing the voltages at these 3 analog pin of Arduino. So when the right photoresistor gets higher intensity, the servo motor rotates in anti-clockwise direction, and if the left photoresistor gets higher intensity, it rotates in the clockwise direction. And when the upper photoresistor gets higher intensity, it rotates toward the upper photoresistor, and if the lower photoresistor gets higher intensity, it rotates in the opposite direction. And they all will stop rotating when all 3 photoresistors will get equal intensity. In this way, solar panel will always be facing towards the sun. So this was my assignment. Thank you.